Alright, so today we'll be talking about pricing strategy. This is a short, self-contained 15-minute lecture that could be expanded to cover more detail. So, imagine that you're a producer or a supplier of some good or service. For the sake of this lecture, let's assume that you're looking to open a burger shop in Brisbane, and what you want to know is how much to sell your burgers at. And so first, what should be your goal? Well, if you're a money-minded capitalist, your goal should be to maximize profits, right? So your goal is to maximize profits. And in order to maximize profits, you need some understanding both of the cost of production, of basically making burgers, and also the demand for what you're producing, burgers in this case, in Brisbane, right? So let's start out first with the cost. So if you're producing burgers, what will you need? First, well, you'll need a place in which to house your burger shops. You need to lease some sort of commercial real estate. You'll probably need to buy or rent some kitchen equipment. You might need some furniture, cutlery, wallpaper, artwork, whatever that contributes both to the user experience and to the ambience in your restaurant. You'll also probably need to spend some money on advertising and marketing to make sure potential customers know about your restaurant. All of these and related costs can be referred to as the costs of capital. And in addition to capital, you'll probably also need to hire some staff. So you'll need cooks, you'll need servers, you'll probably need cleaners, you might need a manager, wait staff, cashiers, etc., etc. And that can be collectively referred to as your labor. Capital is usually denoted by the alphabet K. Labor is denoted by the letter L. Once you have both your capital and your labor, you're ready to start making burgers, right? Now the question is how to price these burgers. So let's say that this is a chart where the x-axis denotes the number of burgers, so the quantity denoted by Q, and the y-axis denotes average costs. All right. And I'm going to switch just to keep things clear. All right. So initially, as you increase the level of production, you'll notice that your average costs decline, and quite dramatically at first. Why is that? Well, what's happening is that the initial costs of capital are being spread over a larger volume. You probably need the same restaurant space, you probably need the same kitchen equipment to cook 20 burgers as you do to cook 10 burgers. And so when you go from producing 10 to 20 burgers, that upfront cost of the restaurant space, the kitchen equipment, etc., is being spread over a greater number of burgers, and so the average cost of a burger is going down, right? And that's what you see happening. This process is referred to as economies of scale. And economies of scale may formally be defined as the idea that a producer producing a higher volume will likely face lower average costs than a producer is producing lower volumes, right? Now what happens is, as you keep increasing production, eventually you'll realize you'll need to hire more staff. So you'll need more cooks, you'll need more servers. As your staff starts to grow, you'll probably notice that more disagreement, more confusion is starting to arise, and so you end up hiring a manager. However, as your staff keeps getting bigger, even with the manager, the restaurant's no longer big enough, the kitchen's no longer big enough, burgers are being produced and cooked at a lower efficiency than before, etc., etc. And so all of these reasons imply that this curve starts to become flatter. And this process is referred to as diminishing marginal returns. And diminishing marginal returns in this context may be defined as the process by which average cost reductions start to decline as the level of production increases. And what do I mean by this more formally? So let's say that initially you're producing some quantity A, and the average cost at this level of production is CA. Now, when you double this output to B, you're facing average costs of CB. Now, let's say that you triple your output, and the average cost that you're facing now can be given by C as subscript C. Diminishing marginal returns refer to the fact that the difference between going from A to B in terms of average cost is much larger than the difference in going from B to C in average costs. Eventually, what will happen is, because of these same inefficiencies that I talked about, your average costs will start to increase. And at that point, we say that diseconomies of scale have set in. Now, your cost function, that's denoted by C. So C is obviously some function of the level of output, Q. And as I mentioned, it's some function of both the capital and labor that you're willing to invest in. For a different set of capital and labor, you might end up with a different curve. As a restaurant owner, you need to determine for the capital that you're purchasing and the labor that you're investing in, how will average costs vary as a function of the level of production, Q. Once you have an understanding of your cost structures, the other side of the story is to understand demand. The demand for burgers in Brisbane, what would it be a function of? So probably be a function of the price for sure. Might also be a function of other attributes such as the quality of the produce, the taste, the ambience, location. Location is extremely important. Other things. So let's denote price by P. Let's denote all of these other attributes by the alphabet A. And so broadly, demand D can be expressed as some function both of the price and all of these other attributes. Now I'm going to try and show demand in the same chart, but I'm going to clean it up first, just to make things easy to follow. So the x-axis still denotes the number of burgers, the quantity. In the case of demand, let's say the y-axis denotes this time price instead of the costs, right? But we're still talking about dollars. So generally, as price increases, you expect more burgers to sell. So typically the demand curve should be downward sloping. There will be no point of inflection as there was in the case of the cost curve, because at no point should demand start to increase with increasing prices, right? So this should always be monotonic. Let's denote this by D given P and A. Now, how do you understand the demand for burgers in Brisbane? How would you go about doing that? There's a couple ways. One is you could survey patronage at different burger restaurants in Brisbane to understand how demand at each of these restaurants varies as a function of the price and all these other attributes. The alternative is you survey a bunch of potential customers, you present them with hypothetical burger restaurants where you weigh each of these attributes systematically, and you ask them which restaurant they prefer to go and how often they'd go, etc., etc., and that gives you the same answer, how demand would vary as a function of these attributes. Once you have an understanding of the demand for burgers in general in Brisbane, you can translate that into the demand specifically for your restaurant. So you can plug in all of these attributes, so you know the quality of your produce, you hopefully have an understanding of how good your burgers are going to be, etc., etc. You plug those in, that will give you the demand for your burgers as a function of the price of your burgers, given all of these other attributes. Once you understand both the cost and the demand, you can start to put these two pieces of together to understand what the optimal pricing should be in this case. And so let's do that next. So like I said, your goal is to maximize profits. Profits can be given by the difference between total revenue and total costs. Well, what is revenue? Revenue is just sales times the price, and total costs are also sales, because that will be the level of production for your burger shop, times the average cost. Right? Now, for a given price point P, we know that the demand can be given by D of P, given A. And for that demand, i.e. that level of production, we know that the average costs can be given by the cost function, and let's denote them by C. Right? So sales are given by D of P and A times the price, which is P, minus the sales, which are again D of P given A, times the average cost, which is C, and C is a function of Q given K and L, and we know that the level of demand will also be equal to the level of production, because we don't want to be making burgers that nobody's going to eat. That's just unnecessary waste. And so Q, in fact, is equal to D given P and A. And so we can just plug that in. And so the optimal price P, optimal, becomes the price that maximizes profit. And that can be given by the solution of this optimization problem, which is essentially just the demand multiplied by the difference in price and average costs. And so your optimal price is the solution of that optimization problem. You can also visualize that graphically. So revenue is sales times price. So for a given price, these are the expected sales, and so the area under this curve, under this rectangle, is equal to revenue. Similarly, costs can be given by sales times the average cost, which is the area under this smaller rectangle, and so the difference between the area of this bigger rectangle and the area of the smaller rectangle basically gives us profit. And so basically you want to pick the price P that maximizes the area of this smaller rectangle, which is equivalent to the solution of this mathematical optimization problem. Once you know your demand function and your cost function, you can solve for the P, and that will give you the price at which to sell your burgers in Brisbane. Thank you.